Welcome friends. I am preparing a video on use of Webpack with the micro front-end architecture, which is very popular nowadays, and I will explain you how Webpack is used along with the micro front-end, minification, parsing React code, parsing Vue code, compressing HTML, compressing images, and this is very trendy topic actually. Webpack is nowadays used very heavily with the front ends, so that we can leverage the important considerations provided by the Webpack. In fact, Webpack is the all-rounder stuff actually. You can see, you might be knowing about that, but today I will walk you through the deep dive of this particular topic. I will show you the code. I will show the how micro frontends work, two different micro frontends work, how they interact with each other, and what kind of configurations available with the Webpack. So let's deep dive, let's understand, and so that you guys can also work on and create any new micro frontend, or even you do not work on micro frontend. Webpack is having so many use cases which are performance oriented, like linting also you can configure. So many things you can do. I will explain everything mostly so that you can understand what role Webpack plays in developer's life, be a front end or be a Node.js backend or whatever. Okay, so let's start. I would request you to watch this video completely so that you understand all the topics. I have done so much of hard work to find out the topics, work on it, create the PPT, prepare the video and showcase it in front of all of you. Thank you very much. Let's move ahead. So now let's understand what is the problem statement. Let's not talk about Webpack first of all. Let's see what is the problem statement. So you might be knowing about the TypeScript, and you also might be knowing that pure TypeScript code is not understood by the browser. So you want to write the TypeScript, but you know that TypeScript code is not understood by browser. So that is one use case. That is one biggest problem. Browser only understands plain vanilla JavaScript, and this is going to be forever, right? Because browsers are trained to understand plain vanilla JavaScript, which we write generally, which we used to write earlier, but nowadays TypeScript and React.js, Vue.js, these all other things are popular. SCSS, SAS, less text stack style sheets written code is also not understood by the browser. What browser understands is CSS, cascading style sheets, but they are not intuitive. These new technologies, SCSS, SAS, less, these have so many new features which you want to use. Then how will you use actually? Because even though you write it and open that file in browser, it will not understand. You need to transpile it, you need to parse it. So this is the problem. Okay, I am telling about the problem only. Now images are not compressed by default. So if let's say there is an image of 500 KB, it will not be compressed. It will be served as it is. So bandwidth considerations you can understand. It will be not performant, right? Because image is bigger. And what if that same image, same display is converted into WebP format, the different format I mean. Okay, so and compressed format. So it will be better performance wise, storage wise, everything. Now React.js code is also not understood by browser. Whatever React code we write, we need Babel for that to transpile. So React developers sometimes don't understand, but this is the truth. Actually, whatever React code you write, we need to transpile that code, and we have a Babel. That's why we can do it, and that's the reason it is properly working on the browser. So after executing build command or start command, it converts that React.js code to the plain JavaScript code and HTML code. This is the background process. That's why it takes little bit of time. but most of the developers don't know about that. But this is the problem statement. Now developers like to use the TypeScript, React.js, SCSS code because of advanced features. There are so many advanced features, single page application things, and image compressions, and let's say linting. Let's say, for example, I want my developers to not put in the buggy code in the Git. This is the very common use case. How will you do that? There are certain things you need to manually execute the ESLint command or TSLint command, TypeScript command. So but using the Webpack, you can achieve that very easily. There are some settings. You just need to load the plugins. You just need to load the loaders, execute them, test them, and it will create the bundler for you. So this is the problem statement. Now let's dive into what is the definition of Webpack. What is Webpack in fact? Webpack is a popular open source module bundler for JavaScript applications. So I don't agree with completely. It says for JavaScript, but it also works with React, images, CSS also, ESLint also it works with. So images are not part of JavaScript. They are independent. Like you can use images in Java, ASP.NET also. Okay. But still, Webpack is a popular open source module bundler. Now, module bundler means what? Module bundler means there are 10 files. Okay. Let's say there are 10 JavaScript files, 1.js, 2.js, 3.js, and earlier what we used to do is load all the 10.js files if we need functionality from all of the JavaScript files. But nowadays it is not the case. What happens nowadays is we have one setting of Webpack. It creates only one file, one JavaScript file. It will give bundle.js or something, whatever name you want to give, and it will bundle that file. That is also minified in the minified format, very compressive, very small, and you just load it, and you don't need to load it. That is what Webpack is going to take care of. Okay, so this is the beauty. Everything you will learn in this video. So it is Webpack is primarily used for bundling and packaging front-end JavaScript modules, and it can also bundle or handle other assets such as CSS, images, and fonts, except JavaScript and TypeScript. So CSS, images, and fonts also it takes care of. I also already told you. Webpack is one of the key stakeholder while developing micro front-end apps. So Webpack is very, very important. There are so many other few other bundlers also, module bundlers also, which you can use. Like you can use Grunt, you can use Gulp. They are task runners actually, not bundlers. And you can use White. You can use some other things also, which are somewhat more or less related to the Webpack, works like Webpack. But this is one of the best techniques I have seen. So before Webpack, what we used to do is we used to write the manual script tags. Like you remember, less than script, index.js, and then something like that. And then let's say we have 10 Webpack files. We used to concatenate, or we used to use the Grunt or Gulp so that the task runner should do something. We need to write the kind of script to perform whatever we wanted. Okay. And we also need to handle the dependency management, what files we need, what libraries we need, dynamically runtime, whatever. Okay. And we also used to do the server-side rendering. You all know what is server-side rendering, right? The files are rendered and keep on the server side so that SEO front or other places we can make use of. Now, this is the traditional web app representation wherein there is a browser, and let's consider there are 4 files: a.js, b.js, c.js, and d.js. So it's a bundle list. Okay, this is not related to Webpack, not Grunt, not Gulp. I am just talking about the plain representation of the traditional web app before all these new bundlers and task runners. So what was supposed to be done is loads one by one file separately. So all the files had a HTTP request, right? You understand? All the 4 files will have one each HTTP request. And what will happen after Webpack usage? What Webpack will do is all the 4 files, it will do the packaging. It will create the bundle.js file, and it will serve for the browser. It will create the bundle and it will serve in the browser, so that it will be very super fast and compressed, minified, so that performance wise or HTTP request wise it is supported, right? You understand all this what I am saying. So I will give you example also. So only one file is prepared using Webpack, okay, and then the file which is created is minified. This is very beautiful thing I am telling you. Let's say the file is of 500 KB, so after minification it can come up to 100 KB also, because all the comments and few things are removed from the application, from the files. So this is how things work after Webpack. So all the JS files, PNG files or JPG files, images, SAS files, CSS files, whatever, all converted into the 4 type of assets. In this image at least I am showing you 4 different type of assets: JS, CSS, JPG and PNG. So these are the static assets which generally Webpack runs and create it for you and keep it inside one of the static folder for you to do whatever you wanted to do. Because this is not that it will we need to do some things after bundle creation. I will explain you everything, don't worry, because we may need to take care of the CI/CD pipelines also, which we already take care, right? We have CI/CD pipelines nowadays, and we put the files at some place so that it will be served. So guys, let's talk about Webpack possibilities and key features. Webpack is very popular because of so many reasons, and once you start using it, you will be falling in love with it, I guarantee. So there is a little bit learning curve, I know, and I agree also. There is a steep curve because we don't adopt what Webpack does in the initial period. But as soon as you start getting the benefits out of it, you will start loving it. So let's walk through what are the possibilities and key features. So Webpack does the module bundling. As I told you, it can combine multiple JavaScript modules into single file or set of files. It can create set of files also. I have created video, means given the example also. And then automatically it does that conversion, means connection that is with the index.html file. It can do the code splitting also, like you can utilize Webpack to your code, split your code so that it can create multiple chunks and load them on demand. So on demand means if it is not needed, it will not load. It's kind of lazy this thing, loading code. So that is the benefit of code splitting. You can divide and have a small number of files, small size files, I mean, okay. There are so many loaders. If you go through list of loaders which Webpack supports, there are so many loaders which you may need for your application, so that you can do whatever you wanted to do. And like for example, as I told you, CSS, SCSS for React parsing, Babel loader also there, image compression layer, minification, ESLint related loaders. Which can check the authenticity of your code if there are some code smells, bugs or whatever. And also very good thing is it can also fix your code if possible. There are some possibilities of fixing your code, means not I mean logical errors not talking about. I am talking about the code smells which generally SonarQube gives. So it integrates with the SonarQube also. There are so many plugins also to convert to the HTML. And it has module federation plugin to create the these micro front ends, okay. And then it has development server. It has also feature of hot module replacement. For example, you make changes and right away the code will change over. So you saw this, you might have encountered this kind of functionality in React.js applications, which is inbuilt. You modify something and it will reload and show the updated text, right? So you can implement that using Webpack also for your plain JavaScript, I mean plain JavaScript code also, like a.js, okay. So this is the beauty. Asset management. Webpack can handle various types of assets like images, fonts and other static files. It can optimize and bundle these assets and automatically reference into your code. So don't need to, you don't need to, even what happens, you will be surprisingly see new files with new names are stored, and those are kind of encrypted file names. So you will be surprised what is going on, but don't worry, your webpack will automatically handle that internally. So it will, even though it is created inside the dist folder, distribution folder, it will internally attach it automatically in the index.file or index.html or main.js or remote entry, whatever. Don't worry at all. It does the optimization by reducing the bundle size and image size also. It can compress. I told you, very important thing. You might have heard about the concept of tree shaking. Tree shaking is a kind of very important aspect in terms of handling the unused code. If there is an unused code in your whole bundle, okay, application, it will remove that code because it has features, it has powers to check if that code is used or not. So while bundling, it will remove that. Let's say there are 500 files. I'm just giving a example. If there are 500 files, and out of which 10 files are not being used at all, they are not included, they are not using anything, doing anything. So by using this tree shaking system, it will remove that code and create the bundle accordingly. So this is kind of miracle, okay? And Webpack, you can do so many configurations also. For example, you can specify the entry point from where you want Webpack to consider the starting point of your application, output paths, where you want to save the file, what should be the name of the files. You can specify the rules and other settings also. So that means Webpack is your slave. You tell him whatever you want. Don't worry, you are telling him. There are some default settings also which you will understand, but majorly everything is related to revolving around the configuration only. So you have to do that configuration if you want to make some changes. It can do the asset optimization also, like compressing code, optimizing images. I keep telling these things so that you understand and you realize the value of this Webpack. So hot model replacement, I already told you. Whatever you are changing right away, you want the page to refresh, like React.js, Vue.js, AngularJS. It has this feature for any type of file like JavaScript or plain JavaScript, I mean, in a.js. Multiple environments. Webpack, the beauty of Webpack is it can have development, test, production environment, and you can configure that using the environment variable. It is a inbuilt stuff which Webpack provides. You just need to use that. No need to. You can also do it manually, like you can create some environment files .env, .prod, whatever you want. But there is a feature provided by Webpack also, so that you can handle that internally using the Webpack only. Integrating with CSS preprocessors. This is very interesting. You want to work with SCSS, LESS, okay? You don't, because in the CSS there are no nested rules, no variables, no mixins. You have to write everything from the scratch. What happens? Let's say there is a CSS and you want to follow one color for one particular day. Let's say there are 7 days, right, in a week, and every day you want to have separate color. How will you maintain in the CSS, plain CSS? You will create 7 CSS files, okay, because there is no variable system in the CSS, right? So in the SSS, SAS or less, there is a feature wherein you can mention the variable and use that variable whatever you want, wherever you want. So this is a reusable type of thing, configurable type of thing. I am not talking about Webpack right now. I am talking about the CSS preprocessor, the facility which we want to use, but our browser do not understand. If you write less code or SCSS code, SCSS code, and want to execute on the browser, it will not understand. But it will understand plain CSS code, right? So what Webpack does is, it has some preprocessors, loaders, which converts your less SAS code into plain CSS, workable CSS, and that too very optimized way. This is what I wanted to say. I hope you guys understand what I mean here. So they are Webpack is able to integrate with different frameworks also. For example, Webpack, you can create the micro front end using React.js, AngularJS, Vue.js, and many more technologies, whatever you know, like Next.js and all. So that is the beauty also. So Webpack, you can configure and make sure it works using the module federation plugin. And Webpack works with individually also. Webpack works with different JavaScript frameworks also, like React, Angular, Vue, and whatever the dependencies are there. Okay, it it is a very good build process and everything. Yeah, so code linting and formatting, this is very beautiful. Webpack can be configured with the TS-lint or ES-lint, like ES-lint and TS-lint is for TypeScripting, right? You can follow the, make sure to enforce the coding standards, whatever you want, and you can catch the potential errors, and it helps to maintain the code quality, and also mostly it will fix the code for you also, but you need to provide that option -- fix. So that means you are giving powers to Webpack to fix the issues, and accordingly Webpack will fix the issue also. This is the miracle actually, okay? But I am saying it will fix some kind of issues. It will not be able to fix all issues, all the code, and it will not fix your logical issues. Please understand what I am saying. It will fix code smells, bugs, or whatever small issues like variable naming, or like it can try to fix all that issues. So I have tried that. That's why I am saying it works actually. Okay. So you all know what is code linting. Generally, code linting happens on the Sonar Cube and all, but this is the very beautiful thing which you can configure using the Webpack also. And if there is any code smell or any problem in the code, bug in the code or whatever, not logical, I am saying. Whenever I am saying Webpack, it will not remove or check the logical issues. So it has a powers that it will not allow the developers to commit the code in the Git repository or AWS or wherever user is trying to do. So understand, this is a beautiful thing. You will get very clean code even in your repo. That means you write some configuration in the Webpack and it will make sure your developer is not writing a bad code. What a beautiful, miraculous thing actually. Okay. So I will explain you everything. Just stay tuned with me. Stay with me until the end of this video. You are going to get so many things and you will learn so many things using this Webpack. Okay. You will fall in love today. You just go through my video completely. You will fall in love. Welcome back, friends. Let's move on to the different architectures which like you see on the screen. One is I have seen the image of monolithic architecture wherein everything is on the same place, right? Interfaces, business layer, database MySQL, MongoDB or whatever database you have. Let's say it is on the same place. It is generally not in the same place. Database layer, database code is there, but database actual database server is always different kind of, okay, in the production environments. So but all the codes, like there are no microservices there, everything is written by the single application. Like HTML is very tightly coupled with the code, like the presentation logic, HTML and CSS are tightly coupled with the PHP, .NET or Java code, the logical layer, I mean, okay. So this is kind of monolithic architecture, everything at the same place. And what happens in the microservices architecture? So this is very famous architecture which nowadays is very popular in 2022-23. Okay. So what microservice architecture does is there are different microservices, literally different repos, and deployment strategies are different, deployment cycles are different, CI/CD pipelines are different, and the responsibility is also different of each microservice. So each microservice does its own job only. It has nothing to do with what others are thinking. And microservice architecture, when we talk about pure microservice architecture, it is said that one microservice architecture, one microservice repo, that one service will be connecting to one database, and that is responsible for doing any kind of CRUD operations on that database. But generally, sometimes it happens that we break the rule, okay, for some reason, but it should not happen. To get the performance, we do that actually, because let's say there is one database called as payment and one microservice called as payment DB and payment microservice. So if payment, if invoices has to do something with the payment, what invoices will do, it will contact to payment service, and it will internally get the data from payment service, payment DB, and then pull it in its own service, okay, and then it give back to the invoice service, right? Otherwise, there are different ways to data communication actually. That is very broad topic again. Like we can implement the queues, we can implement the event bus, we can implement the synchronous communication using REST APIs and all between the different microservices, I mean. But right now I am not going to talk about all that stuff actually, because our topic is main topic. I don't want to divert from the main topic. Okay, it is a webpack, so let's talk about that. But I wanted to give you a little bit understanding of what microservices does. So different microservices, different tasks, different connections to the databases. This is what is expected, right? So this is the backend. Like microservice refers to the backend always, like Node.js, Java, ASP.NET Code, all that. And when we talk about microservice UI, microservice framework, that is also does the similar thing for the front end. So let's say there are different responsibilities like payment, user management like login, logout, forgot, my profile, edit profile, whatever. Those are the separate repos, right? So user management, payment, invoices, feedback, whatever. So each will be having different microservices, and we will consider each of the microservice as a different project. Like it will be a different repo, it will work on the different port, it will have a different CI/CD pipeline, it will have a different set of people working on it, everything. Okay, so consider it as a separate project, but it will be a small project, and at the end all these things will be going on to the database, on the server, and execute is as if it's a single project. So there are some challenges also. We are going to talk about those challenges also actually. What are the challenges? The main challenge is there should be a code which will be reusable by all the microservices. Otherwise, micro UI, front ends, repos. Otherwise, what will happen? You will have to duplicate the code. Okay. So for that, there is a concept of container also. I am going to explain that also. So there is a container where we keep the store, where we keep the common logic, and we share that with the other repos. What that means is container is the one repo which is the whole and soul of that micro front-end UI, and it is shared with all the repos so that the common reusable functionalities can be used by all the microservices. Otherwise, you will have to replicate all the code in this microservice and that microservice, every microservices. Okay, so this is what I wanted to explain. I hope you all are with me and understanding what I am talking about. Monolithic architecture, microservice backend architecture, and microservice UI, which is front-end architecture. So it's very popular nowadays. So that's why I wanted you guys to understand what is the meaning, what is all around discussions and implementations are going on in the micro front-end. Let's proceed on the further slides. So this is how micro front-end representation is. You see on the screen. I have shown you three different teams. One is team cart, one is team website, and one is team payment. So let's consider these all as a different micro front-end, different repo, different CI/CD pipelines to move it, and different people are working on it. And as you see, on all the micro front-ends, React.js is used. But what you can do is you can have React in team cart, you can have Vue on team website, and you can have Angular on the team payment. So don't worry about it, because Webpack is going to handle everything: parsing, creation, building the JavaScript. Because at the end, what executes is your JavaScript and HTML only. Even though you write the code in React.js, what happens in the end? Babel loader will going to parse, and it will transpile that code into the plain JavaScript only. That's so that browser can understand. This is the miracle which is going in the backend, which we don't know generally as a developer, right? But this is how it works. So that's the logic behind it. So micro frontend is an architectural pattern of building modern web applications by decomposing a large front-end application into smaller, self-contained and loosely coupled micro applications. Right? So they are not tightly coupled. I hope you know what is loosely coupled and what is tightly coupled. Loosely coupled means they independently work and they have no dependency if other micro frontend does not work. But in this scenario, only one place is connected, like container is connected to every other micro frontend. But I'm talking about all the other except the container I'm talking about. Okay. Each micro frontend application corresponds to a specific feature or functionality of the overall application and can be developed, deployed, and maintained independently. So I explained all this stuff earlier, right? In a micro front-end architecture, the user interface is composed of multiple micro applications that can be developed using different technologies. I told you that we can use plain JavaScript, we can use plain TypeScript, we can have React.js, we can have Vue.js in the similar application. and Webpack is responsible for parsing it and creating a bundle out of it. So don't worry at all. Okay, you can do anything. You can have different set of people, different skill set of the people, and write the code accordingly. Each micro application is responsible for a specific domain or user journey, and they communicate with each other through well-defined contracts or APIs. So you can connect the micro frontends with the different things like there are two things, like one is build time and one is run time. So we will talk about that also in this video. So that is very important aspect to understand as a developer, what is build time and what is run time. Okay, so we will see both the approaches, and it's very important in interview question. In fact, every Webpack and front-end developer must understand what is I'm talking about. So key characteristics of a micro front-end, it allows the independent development. Every person can write separate code on his own repo. They are loosely coupled, they are not very tightly coupled with each other. That's why they promote the scalability. That means if any particular UI repo is going to use a lot of times, or it is a very important, so many things are there, you can make it more scalable also, flexible also, right? So, scalability, what is the scalability? You all know, right? Scalability means the power of horizontal. Scaling means, based on the demand, you can scale it, right? For achieving the better performance, or if you think that there are 10,000 users, your system should work, and at the same time, if 1 million users logged in on any particular important day, your application should not break. So this is nothing but, this comes under the scalability characteristics. Okay, so micro frontend is a seamless, performs the seamless integration also between the different components and different microservices, micro frontend, and it can have own CI/CD pipeline, continuous delivery, deployment, independent testing, release cycles, everything. But when I say release cycle, means you can release payment microservice on one day and card microservice on another day. There is no tightly coupling. You can also maintain the versions also. So that depends on you, how you are implementing that. You can break down that monolithic front-end application into smaller manageable parts. So it's not that everybody is jumping on one monolithic architecture. There are different things, different front-end teams are working on the separate repos, and this way you can create very large scale project also. You can do the incremental micro front-end migration, I mean, so that let's say you have a very big monolithic architecture, you can divide into smaller pieces and accordingly incrementally work on it and achieve whatever you want. It is it works on the isolated environment because everything is different for each micro application, right? As I told you, I keep telling you every time. So every micro front-end application provides you a facility of independent deployment also. So what does that mean is payment micro front-end will be different, your cart micro front-end will be different, entire application is different, having so many repos, so many deployment cycles you will have to do, right? So overall, micro front-end promotes modularity, scalability and maintainability. You can maintain very easily, you can scale any kind of repo as per its need and demand, because you are breaking down application into smaller manageable units, right? It's not a very complex thing, it's a small thing, just the communication stuff. I'm going to explain you how it communicates. I have written the code also. I will show you how micro front-end interact with each other also. Don't worry at all. They will interact with the different ports on your local system. I will show you everything. So let's move on to the other topic, guys. Thank you. So let's talk about the very important topic now, which is Webpack config file, which is the heart of Webpack actually. There is nothing other than Webpack config file configuration actually. You can do Webpack configuration here and see the magic. Okay. So it's very important for you to learn how to configure the different modules, different loaders, plugins, entry point, output, port number, and all the configurations. It's very simple. Don't worry at all. Just listen and watch this video, and you will understand everything. Means you can even crack the interview also. I am very sure. Don't worry about that. So let's walk through it. What is the default file name? It's a webpack.config.js. Okay, default file name is webpack.config.js. So it's in the JSON format, as you will be able to see this. So that module should be exported, and syntax is module.export or exports. Okay, Webpack handles these import statements and ensures that the appropriate modules are included in the output bundles. So an entry point is the starting point. There is an entry point in the Webpack. You need to provide the entry point. It's the file that Webpack uses to build the dependency graph for your project. What is the meaning of dependency graph? Dependency graph means you made the entry at one place, and after that your application need whatever other files or other components or other CSS images, whatever, it started analyzing and getting those dependencies. Dependency is what? Different files, different folders, different images, different assets. Okay, so don't worry with this difficult word dependency graph. Okay, so it's nothing but the things which are required by your application. The dependency graph represents how different modules in your application depend on each other. Webpack starts from these entry points and recursively follows the dependencies to create a complete graph of all the modules needed by your application. So Webpack, whatever the entry point is, it will start from there and means go through all the files as per the dependencies you have imported and exported. Okay, so once Webpack has processed the dependency graph, it generates output bundles. Now what is output bundle? Output bundle means there is a folder. You can create that folder and keep it in the root of your application, and there you can put the files, and the folder name and file names are dynamically given. Okay, so you can give whatever is as per your choice. So all the assets and code will be put there. So what kind of code will be there? As I mentioned, browser, whatever browser understands. So browser understands plain JavaScript, plain CSS. Okay, so always keep this in mind. Browser does not understand your React.js code, your other code. So you define the output configuration in your Webpack config using the output property. The output configuration specifies where Webpack should place the generated bundle. That is what I told you, right? So in the next few minutes you will understand what I am talking about. When Webpack generates the output bundles, it combines the modules from the dependency graph and their dependency into these bundles. So the resulting bundles can be included in HTML files. So it creates one index.html file, and that index.html file contains the dependency, like whatever JS file is created, it included automatically. Okay, so whatever dependencies, all the dependencies will be included there. So entry points define the starting point of your application, and output bundles are the result of the Webpack bundling. So Webpack takes some code and gives some code. This is what every time you need to understand. What is Webpack's work? It takes something, processes, parses, transpiles, polyfills, whatever it does, and after conversion, it can provide you the optimized code, images and compressed images, and it keeps you in one folder so that you can take it from there. Okay, so everything can be automated. Don't worry at all. Everything can be automated. Now you see in the code, in the left side I have shown you the code. You see the entry here. This is the entry. I have told that src, go to src and app.js will be my entry point. This is what I said. And output file will be bundle.js. You see here output object is there. It is a file name is bundle.js, and the path means the folder. So what I am saying, current directory dir, okay, current directory, make the folder as dist and put this bundle.js inside this dist. Okay, so whenever you run this Webpack, what will happen? It will create a dist folder and it will put bundle.js, and that bundle.js will run with the help of index.html also. Don't worry. Okay, so multi-entry points I wanted to show. In the last example, you see the single entry point. I am myself telling because so many people keep asking me, is there possibility of having multiple entry points and multiple outputs? Yes, there is a possibility, and this way, like entry object is there, you see entry object and output object. So in the entry object, what I am saying, with the name of app, this is the entry point of app.js, and admin.js, and the output will be similar. File name will be this bracket name. So always understand, this name will replace this name, entry name. Okay, app, like you see on the right side here. Okay, app.bundle.js and admin.bundle.js, like this. And the similar, that means output will be two files, app.bundle.js, admin.bundle.js. Entry will be two files, app.js and admin.js. And where it will keep, you see dist folder, it will keep inside the dist folder the two files. Which two files? App.bundle.js. You see here I have given the example. I will show you everything whatever I am showing in the PPT also. So just stay with me. Webpack modules export, it supports both the modules. There are two types of modules, one is ES modules and one is common module, common JS module. Okay, so .mjs extension is there, and it can support and it can parse all that also, right? And here if you see in this configuration what is mentioned, I will explain you one by one. So what it is saying, it has created a rule. Rule is an array. It can have multiple rules also for one webpack. So for the test option, I am asking it to either have either parse .mjs file or only mjs files. Okay, this is all a regular expression. I am not going to teach regular expression. I am asking it to exclude the node modules because node modules have so many files. I don't want it to parse because I don't have anything to do with that. I want to use the Babel loader, and all of you know that Babel loader is responsible for parsing the React.js like code and create the HTML, React.js and this one JSX code, right? And presets is Babel and preset environment. So this is what I wanted to explain. Okay. Second thing is CommonJS. CommonJS is a kind of commonly like Node.js. Many existing JavaScript projects also it is used actually. And this is how it looks. It's kind of similar actually, right? There is no much difference basically. The difference is in the plugins only. Let's talk quickly about differences between CommonJS and ESM. ES modules are ESM means M for module. ES modules use a standardized syntax with import and export keywords. CommonJS modules require to import modules. So there is this is one of the small difference actually. Okay, not very big thing, but there are few important considerations here. Like ESM are statically analyzable, which means the imports and exports are resolved at compile time. Now compile time means what? It compiles the code before running actually. Okay, so at that time it can analyze. Okay, so this is why it can optimize the module dependency during the build process. That means at the time of creation and the output files, at the time only that compilation, that checking, that everything is performed. So that is very important aspect in terms of performance. Okay, and what is the difference and how it is different? CJS is different. It is dynamically evaluated, which means import and exports are resolved at runtime. The dynamic nature of CJS can make it more flexible but less efficient for static analysis. So the runtime and build time, I told you what is build time means at the time of compiling, at the time of building the static files, it does everything and creates you runnable code, gives you runnable code. But runtime means what? At the runtime only it checks and performs all the operations. So it is not good use case. In fact, this is very bad. I mean, from the React CJS perspective. So browser support. ES modules are natively supported by modern browsers, whereas CJS are not natively supported by the browsers. And for example, few things are not supported by the older browsers related to ESM also. So Webpack can transpile it and bundle them again so that it works. Which is not very efficient in CommonJS modules actually. We typically need a bundler like Webpack to transform them into format that can be understood. So it should be as it is a runtime. That's why there are so many problems with the CommonJS also. Okay, so tree shaking is one of the best feature I can tell you guys actually. If there is a code which is not in use, it removes the tree the code while the process of tree shaking using Webpack, but it is not possible in the CJS. It happens in the ES modules only. So because of the static structure, it is possible to remove the unused code, and because of removing the unused code, it is very fast. It's very simple, right, to understand, because if there is no unused code, performance will be increased. Only the code which is running will be present in that bundle, output bundle, right? So this is the difference. And as I told you, this is the summary of the difference is, ESM offers the standardized syntax, static analysis, and native browser support. They are more efficient in terms of bundling and tree shaking with Webpack. On the other hand, CommonJS modules have a more dynamic nature and require a bundler like Webpack to transform them for browser usage. And the biggest drawback is, it does everything on the runtime, the CommonJS. Okay, so that was not related to Webpack, but I just wanted you guys to understand about this also. So this is the code. I told you that in importing, how do we import in ESM? We need to use the import statement. You see in the left side, on the right side, you see it's using the require module, right? So exporting is all same, but importing is little bit different in ESM and CJS. So let's move on to the other topic, which is loaders and plugins, which is the heart of the Webpack configuration file. These are very important building blocks to run your React code or JavaScript or optimization or whatever, because other than loaders and plugins, Webpack cannot do anything actually. You need to understand this very easy, so there are very essential concepts in Webpack that enhance its functionality and allow for the transformation, optimization, processing of different types of files and assets in your project. So loaders in Webpack are modules that are used to pre-process files as they are added to the dependency graph. I told you about dependency graph. Now pre-process means what? It creates the static file before execution, while at the time of compilation, I mean. So they help Webpack understand and process different file types and transform them into valid modules that can be included in the bundle. So they are specified in the Webpack configuration to handle specific file types or apply. So we need to mention which file type Webpack loader needs to consider. You will understand in the next example. So what is a transpiling means loaders like Babel loader enable the transpilation of modern JavaScript to a backward compatible version that can run in old browsers. So let's say you have an old browser and it does not understand the new feature actually. So as you all know, as per the setting, Babel loader can make that code working on the older browsers also, right? So you can use the Babel loader inside the Webpack. So this is kind of third-party integration. Styling. So I already told you that loader like css-loader are used like to import to convert your SCSS less code into plain CSS code so that browser can understand. Asset handling. You can use file loader and URL loader to handle the loading and bundling of various types of assets such as images, fonts, and other media files. Whatever media files you have, whatever things you have, like they need some loaders like file loader and URL loader so that it will pre-process and create while at the time of compilation. So it does the code analysis with the help of ESLint loader. You see ESLint-loader. Or for the TypeScript, it uses ts-loader and check the code for linting errors and inform accordingly. Whatever you want to do, you have to write in the Webpack configuration and it will do it for you. So you see on the screen, you have to provide whatever loader you want to do, you want to use in the module.rules. Rules can be an array. It can have one or more elements in that, and one element can execute the rules. You see in this code, in this rule, Babel loader is being used, right, for loading. What I am saying is to parse the .js files using this Babel loader, and these are the options actually. Okay, so this is very straightforward thing. Don't need to by heart, don't need to remember these things. You will find this setting on Google also. Just you need to understand that everything is a JSON. So plugin in Webpack are modules that extends its functionality by performing a wide range of tasks throughout the build process. So they can be used to optimize bundles, inject variables, manipulate chunks, extract CSS, and much more. Okay, so plugins has its own role actually, and they are instantiated with the new keyword and added in the area of webpack configuration. So you see one of the plugin is Uglify JS webpack plugin. What it does is it does the minification. So there is a JavaScript code with the written with the traditional programmer. We want it to be modified to minify, like not modified, we want a minified version. We can use Uglify plugin actually from the webpack. We want to generate the HTML. There is a plugin called as HTML webpack generation. Okay, webpack plugin, sorry. It will create the HTML code actually, so that it will understood by the browser. Asset management, you see asset means CSS files are extracted into separate files, and for that you can use mini CSS extract plugin. Environmental, for environmental injection, you want to use some environmental files like .env. For that you can use webpack.define plugin. What that will do is you can take all the variables from your environment variables and keep it in your code like process.env. something. So I'm not going to tell you what environment variables, how it works. As a React developer, as an Angular developer, you guys might be knowing about this actually, how environment variable does. So to use a plugin you need to install it. This is very important. Without installing you cannot use it. This is how React.js, AngularJS works, right? And then you need to import it. So loaders and plugins, by leveraging these, you can customize the functionality. Whatever you want to do, you can implement. So I will explain you like how to install. Just quickly I am going because I know these are very simple things which developers have hands-on practice. HTML webpack plugin. They are you can use this command npm install savedev HTML webpack plugin. Why savedev? Because in the production it has no use. Because why it is no use? Because you are not going to execute this command. You will be getting the bundle, output bundle, right? That's why. So that's why --save--dev is important here. Npm install clean webpack plugin. If you implement this and use it, what it will happen is before creating new bundle in the output folder and path like dist, it will clean that so that all the earlier code will be removed and there will be less chances of cache problems and different things. So existing files are not there and every time new file will be moved over there. Mini CSS extract plugin, as the name suggests, it will minify your CSS. This optimizes and minifies CSS assets. So this is the different plugin. So there are optimization. The first one is for minification, second one is the optimization. So internally it does so many things actually. So you know, let's dive into the another topic in the next video. Thank you very much for staying along. Just again one more request, stay with me, check the complete video. You will going to learn so many important things about the webpack and micro frontends. Thank you guys. Let's talk about micro frontends now. This was the background which I was talking about, webpack and all. And now let's dive into the micro frontends stuff. So micro frontend is an architectural pattern that extends the principle of microservices to the front-end development space. So what microservices is for backend, it is the same thing for the micro frontend is for the front-end development space. So what we do in that micro frontend architecture is to decompose the front-end application into smaller, loosely coupled and independently deployable units. Okay, so they are pointing to different microservices. One micro frontend MFE has one repo and it has one separate CI/CD pipeline. Each micro frontend represents a distinct area of failure of the overall application and can be developed, tested and deployed independently. So that means we deploy the micro frontend independently, as I told you earlier also, and accordingly it works. So so it has a container application. Micro frontend has a container application which is the heart of the application and in which holds everything. So this is nothing but a host actually. Host is very important. Host and remote, these are two things which micro frontend component, micro frontend architecture always possesses. So host and container both are same. So whatever settings and whatever configurations, important configurations we have like exposing, remote, this one, everything is handled from the container. And generally state management and centralized middlewares also are written in the container application only. You will understand going further. So these are just the terms which I am explaining so that you understand. And routing and navigation are also handled from the container, because let's say you have 10 different repos. So it is not possible for you to manage the routing from all the 10 repos. So you do routing from only one repo, that is a container. So container will only contain the centralized thing which are there, and this is a host. That's why it's very, very important. It should be always in on mode. We cannot keep it in the off mode. Okay. And communication, they exchange the data. Micro frontends need a way to communicate. How do they communicate? There are different ways. Like they can do Redux state management in terms of React. They can have event bus. They can use the local storage. They can maybe use the queue. Whatever is there actually. Okay, so everything can be done. So it's very important thing that communication should happen between the micro frontends. Otherwise, it will of no use. Styling and CSS are little bit challenging. Why? Because we cannot have separate stylings for each micro frontend repo. There are 10 repos and we cannot have 10 different styles and maintain everything on 10 different repos. So if we maintain it on the central place. I have created video on that also. Okay, so we do the linking and we do the sharing of that styling and CSS. Building and deployment, they are deployed independently, as I told you, and they have their own build pipelines, frameworks, deployment mechanisms. So all that stuff, release management and everything. Cross-cutting concerns actually. So they are having the authentication, internationalization, and internally they are using the module federation plugin. They are internally authenticated actually in reality, because one MFE exposes some components, other MFE takes that as a remote. So both are doing the handshake. That's how they are authenticated. And overall, the microservice architectures allows teams to work independently, iterate faster, and scale their front-end development efforts. So reusability, modularity, everything is properly taken care of. Now, I am giving one example how it we can implement. So let's consider that we have 4 micro frontends, out of which one is a container. That means host. So host is running on port 3000 on your local system. As I am talking about React.js application, so I will talk in that context only mostly. So the URL can be localhost colon 3000. The second is user management, wherein I will handle the login, logout, my profile, edit profile, registration, reset password, and all that stuff. So it will run on localhost colon 3001. Appointments module, let's say there are appointment related stuff in your application, so it can run on localhost colon 3002. And payments module, wherein you can accept the payments, you can accept the credit card stuff and everything. It will run on the 3003 port. For implementing this micro frontend, you may need to have use the plugin called as module federation plugin, whose job is to connect with provide the infrastructure to connect with all the different repos. They internally connect with each other using the WebSocket technologies, and this is how it works. So it also allows the dynamic loading and sharing of JavaScript modules across different applications. So 2 things, one is runtime and one is build time. So you can, when you talk about runtime, that means at the time of execution only you are connecting to different MFEs, and accordingly sharing the module between different resources and different components and different MFEs. I mean, this is the runtime. But when we talk about build time, that means we build and we create the static files, which I have already explained you before this video. We create the static videos. We create the static files in one application in folder that is called as dist or distribution or production, whatever you want to rename it. And we keep all the files in that, executable files in that are the static files, and you keep it anywhere. Like you can keep it on S3 bucket and it will run. You can keep it on any particular folder and it will run. Okay. It's the runtime stuff, build time stuff, and runtime is, I told you, every port should be accepting the request. So micro frontend module federation plugin enables a seamless integration between the micro frontends. So there are different advantages of micro frontend and module federation plugin. What is the advantage? It allows to share the code between two micro frontends. This is why we are using micro frontend. Otherwise, there is no. This is one of the important requirement also while using the model federation plugin and micro frontend, which will save the code duplication also, and it will enhance the development because one code will be at one repo only, right? We can implement the independent development on all the different repos. We can get the improved performance because we can enable the lazy loading, suspense, and lazy features are there in the React.js also actually, and we can improve so much performance by compressing, optimizing the images. So many things we can do, and module federation plugin we can seamlessly integrate the different MFs and different repos, which I am going to show you very shortly. I have written the code also. I am going to show you that all. Okay, it's a technology agnostic. That means all the different technologies you can integrate using React, Angular, Vue, or whatever. You can do the scaling and decoupling. So scaling means any one particular MFE you want to have on a higher scale, you can increase it. So you can have it on the CDNs also, or S3 buckets also, or anywhere like you want. Okay, encapsulation means other MFE don't know what one MFE has implemented in which method. It just gets that component and executes. That's it. It doesn't know the internal executions, whatever is happening inside the other MFE. When I say MFE means micro front end. Okay, so advantages I have told you. It simplifies the integration and collaboration between micro frontends, providing code sharing, independent development, improved performance, and seamless user experiences. So it enhances the benefits of micro frontend architecture. Okay, so let's talk about configuring Webpack for micro frontends. I am going to show you some code, and I will share the code on my screen also. So we have to have some libraries and loaders actually when doing this. We can have the shared npm packages also here, and we can have a monorepo approach wherein all the code will be on one workspace only, so that it will be easy for managing. And I already told you that module federation plugin is responsible for running the code runtime, different MFE, and connecting with each other, so that you just need to make some changes in package.json files and webpack config files. We can have the shared git repository also, and so that you can put your code in multiple repositories, or you can put the code into one git repository also, and put that git repository into the production database while deployment, right? So you can have HTTP request also at one place, state management at one place, APIs at one place. Like one place, when I say, that means it can be a container or one repo, and you can utilize them in other services. So obviously you have a reusable components, like let's say header repository is there. So header code is header and footer code is needed in all the pages. So you can reuse that in different MFEs. That is how you can share the code. Okay, so always establish the versioning and compatibility practices. Why? Because your code, let's say I said there are 4 MFEs. So one code can have dependent code on another MFE. So you must have the version management in place, so that it should not break. Okay, so one version should connect to another version only. So you need to also document the shared dependencies. This is just I am telling you the best practices, because it's very important. Otherwise micro frontend implementation can be very, very challenging. And always think about what kind of technology stack you are going to use, what is the team structure, who will do what, and accordingly start working on that. So you can also combine multiple approaches also if it suits for your implementation, and you can do that. So to configure module federation in Webpack, you need to make changes to both the container application and the remote micro frontends. So this is the example how it is done. So you see on the first line, HTML Webpack plugin is imported first of all using the require method. And module federation plugin is also received here, so that we can use here. You see both the plugins which are constant variables are used here. We are creating by using new method. I already told in my last video. So let's say in the you see in the module federation I am giving the name, and it is a container, so you can very easily understand that this is a container application. And I am talking about the remotes. So how many remotes I have two remotes here. One is 3001 and 3002. So the name is remote 1 at this remote 2. So these names are very important. These names are very, very important. You will realize what critical role they play actually. Okay, so here if you see, this is the remote, this is the webpack configuration of another MFE, which is a remote 1. You see in the last thing, this is the container, right? How do you know what is this? You can see the name and you can recognize which webpack JSON is that, webpack config is that. And this is calling two MFEs, one is remote 1 and one is remote 2. So this is remote 1. I am telling the remote entry file here. File name can be anything. So default is remote entry generally. And I am exposing the button component here from remote 1. And exposing means I am allowing any other MFE to use my React.js code. This is what I am saying. Okay. So button component I have implemented, and I want anybody to use that as a shared repo. And then here I am saying that it should be at one point of time there will be only one React this one, and accordingly. So now important thing is here what container is doing is it is not exposing himself. You see container is not exposed, so nobody can get hold of container code, but it is mentioning that I will have two remotes. One is remote 1 and one is remote 2. Remote 1 on 301, remote 2 on 302, right? So this is very important to understand. And what this guy is doing, remote 1, it is just exposing his button component. It is not saying that I need any remote. If we can have same component, same repo as a remote as well as the exposer. Okay, so you need to understand this is very important. But I don't want, that's why I have not given that configuration. So name represents the name of the remote micro frontend. File name specifies the name of the generated remote entry file. You can change anything, like you can change the name, you can change the remote entry file. And exposes is very important. You can have one or more different component also. So don't worry that you can only share only one component. You can share as many components as you want. So okay, so build and deployment strategies. So let's talk about this. What are build and deployment strategies? So to build individual micro frontend webpack, you need to set up separate webpack configuration for each micro frontend. So create webpack configuration for each micro frontend. So what I'm saying, every micro frontend is a different repository, and they will only take care of their own code. Okay, so let's say user management, when I talk about, so user management will have one webpack configuration, payment will have another configuration, and container will have different webpack configuration. So default webpack configuration file name is webpack.config.js, but it is not that you have to always use that only. You can use other also. Don't worry about that. So understand this. We will have a separate configuration for each, and separate loaders and plugins for each. So I have shown you another example. There are two micro frontends, micro frontend 1 and micro frontend 2. So I will create these two micro frontend configuration files at two sites. Name can be as per your choice. Don't worry, don't think that whatever I am saying is the right thing. You can have other name also. Okay, so in each of the webpack you can specify entry file, you can provide output path, loaders, plugins, linting, whatever you want to do, you can do everything. So on this screen you can see there is the entry, and file name entry is index.js and output is bundle.js, which will be storing in the dist folder. I already told all this, right? So whenever I will execute this, it will create the output and put it here. So rules, I have not added any rules and plugins here, but you can, as in the last slide I have shown you, there can be loaders, plugins and rules you can mention. So To execute this webpack configuration, you can call npx command. It will not run from the npm command. Always remember that. You will be confused why it is not working, but you need to use the npx and accordingly execute that. If you want, you can install the webpack plugin and then only it will work on the npm also. Okay, so I am trying to give the configuration like npx webpack and then saying config, and config file name will be this. You can have any other also. Okay, and it will, whenever it will run, it will create the bundle.js file inside the dist. I have shown in this place here, and I will show you in the next video also, in the current video also. Okay, so whatever number of micro frontends you have, you can have so many configurations, whatever as per your understanding and requirement, and you can execute everything. So everything will be the individual micro frontend with separate configurations. Everything will have separate CI/CD pipelines, and everything will have different keep their files in the different folders. I have shown you in the remote one repo. It will keep in the dist remote entry. In the remote 2, you can keep in the dist remote entry. Same, right? The folder name is same, but the main repo is different. So friends, welcome. This video will certainly make you very happy, because what I am doing here is showing you how actually I have implemented the micro frontend. This is very small thing, like it's not very big thing, but I just want you to understand how it works. Like there are two different repos which I have created. On 8082 port, I have created the container, and on 8084 port, I have implemented the remote. Very simple, not very usable or whatever, but for understanding purpose, it is sufficient. Okay. So on the remote port 8084, you can see I have this much code displayed, right? This what I have done is to so that you can understand. So remote port 8084, and if I click on this, it will show it in blue or red. If I click on below, it will show in the blue. That's it. Very simple implementation. Okay, React.js implementation. Now, if you see on the container, what I have done on the container side, on the top there is a container code. On the bottom there is again a container code, host code. But on the center, if you see, I have pulled the code from there. Now you will see I am showing something, wrong thing or something. I will make change in the code right away in front of you, and I will show you. Okay, so this is the remote side. Okay, I am writing changed. Okay, I have written change, nothing very major. You see here changed, and now the same thing. See, video is on. I am not doing anything fishy here. Now once I update this, reload this page, it will show changed remote code. You see here. Okay, you got it? So it is changed. Means I was right when I say that I will make change in only one repo, and it will reflect in the other repo also. So this is what. Now I will tell you how it is implemented. It's very simple, simply done with the help of Webpack actually. Let me go through step by step so that you understand. Okay, so you realize like this one is mentioned on this one, right? If you want to see, I can make the change now also. Let me mention change, go there, and it will reload and see changed. Okay, so this is the host and container, correct? I have made this change. Now here what I did, you see, very simple thing actually. What I did, if I have pulled Hello React app. This is my remote app actually. I will show the code, don't worry. So Hello React app I have pulled from the remote, and what is that inside the component? Let's open that also. Component in Hello React app. Okay, this one. So what I did from here is I have gone to Hello React and pulled this Hello React app and mounted it. That's it. So this is the beauty of Webpack actually. What I did, I will show you here also. When my start command will run, it will execute using the webpack.dev.js. This is the entry point. I have run npm run start. It will call this command, webpack serve config and this one. Okay, I told him which configuration file system has to consider. Now let's go to webpack.js, dev.js. What I have done here, I have requested for this merging plugin. Then what I did, I have received this common file webpack.common. Where is that? Here. So what I did here is I have written the common code. Don't get confused. This is the production like environment wherein we have separate common file and separate individual file, because there is a facility in Webpack to merge both the codes using this merge plugin. That's why I did same way. So this is the dev environment. Let's say I have a test environment, SIT environment, UAT environment, production environment, staging environment, whatever number of environments. I will only create file with small settings. That's it, and I will merge with the common file. That's why I did. So don't worry and don't think much about this. And then what I did is model federation plugin I have made use of, which is very important for talking between two repo, communication between two repo, right? I will tell you how. Means step by step I will go, and then I have included the package.json. Now what I did actually, I have said mode is development. So if you do not provide the mode, it will be development only default. And I said output will be the public path will be this one. On this URL, my code should be displayed 8082 port. Okay, so I have mentioned the port here 8082. You can have 80 port, you can have 81 port, you can have 9000 port, whatever you want. And then I am using this plugin. The plugin is calling for module federation plugin and its name is container. So this module name is container, which I was talking about. The name is very important, and it is asking for the remote help. From where? It is asking the help from 8084 port, right? This is the very important 8084 port. So you see 8084 is this one, right? And then hello react is the name of that application. That's why I mentioned here. So let me show you that name also, otherwise you will get confused. So in the webpack.dev.js, you see the name is hello react. See here, the name is hello react, right? It's very important. If name is different, it will not work. And I'm using two things, hello react and hello react app. This one exposes. So forget about what is exporting. Is exporting this file, but it is putting into this place, this placeholder. So this placeholder, these two placeholders are important. How I can use these two placeholders, I will show you. So here, if you see this one, this is the name hello react, and this is the placeholder hello react app. You got it? This is the container and host command, MFE repo, and it is calling from hello react and hello react app placeholder. This one. So this is the confusing part, but very important. Means these two things, hello react app and hello react app. These two things are important. You can have any other name also. Don't worry. I am just telling you the connection between these two things. Okay. And let's go back to container. I am on to container now. And webpack.dev.js. Let's see if anything. Yeah, no. So I think I have explained this. So about this merging of common config and dev config, this is nothing but to merge this and run it. That's it. So don't think much about this. I am just telling about webpack.dev.js to have the self output public path, to have the self port, and to have the self name container to get the remote repo. This is what I did from the container, and what I did from the this one. This is the remote repo, right? So you see the name. It is a hello react. The name is hello react, and the placeholder name is hello react app. So what it will do is it will recognize by this name always, because we are asking our users to do that, right? The public path is different here, 8084. You remember what was there in the container? It was 8082. That means container will run on 8082. This is the remote, and it will run on 8084. So port I have given 8084, and again used module federation plugin. I have given the name as hello react, and the file name I have mentioned as remote entry. This is the default name, but you can give any other name also. but generally people provide this because this is very simpler to understand. Now I have taken the bootstrap code. Let's see what is there in the bootstrap. SRC bootstrap. Okay, SRC bootstrap. I have went there, and what it is doing is it is doing something, and it is mounting into one selector using this query selector and putting on the exporting it. That's it. So it will make sure that the code is provided to this one. So before that, you need to understand what it is also doing. It is pulling the app code. Okay, it is importing app code, and accordingly you see here what is happening. App component is called here. That means it asks the render to execute the app. Now it will go to app, and app.js, what is done, I have written all the code which you were looking on the screen. So this one, whatever information I had given, and accordingly the code is running. And the important thing is the Hello React app. As you know, what is this Hello React app? Hello React app is nothing but the remote repository completely, but this container has received in the one variable, one component only, as one component. Okay, so this variable will contain complete component, and what I did, so it is kind of local to this container. So you need to think in that line. Whenever you import the component, different component, what happens? It will give you in one variable, right? So that variable you can use anywhere. So same way, hello world, hello React, all these are components. So what I am saying, whenever there is a URL change and it will say React, it will call hello React, and if it is different, you like it is a slash, it will call hello world. So this one, okay. So what I did here, using this system, if URL is changed, it is pulling the remote code and accordingly showing the running, right? So again I am showing you, if I click here, it will show in blue, but this code, this up from this to this all code is running on the remote repo. I will tell you, I will show you, like see, this is 8084, this is the remote repo. I will tell you, let's 1 minute. You see the URL, it is 8084, right? Let me close it. I am closing it. It is closed. Now let me reload this. This is the remote port 8084. It should not respond, correct? It is not responding because I have closed that. Now let's go to this one and let's try to execute this. It is not executing because I have not handled. I can handle also if it is not received or not working, then how to behave, but I have not handled that. But it will show you the error here. What it is showing? It is saying that it is not able to load this one. You got the point? This is 8082, but it is dependent on 8084. You see this one, 8084, right? So this is what I wanted to show. This is very important example and very simple example I can tell, but look, implementation is not that smart. I have done in my real projects, what I did is, if that MFE is not responding, I have handled and I have made it working. But here, for example purpose, I did not put so many efforts, but I wanted you to see what is going on in the background. So let me again start so that you can really make sure that, okay, whatever I am doing is in the micro front end only. So I am using two different ports, one is 8082 and one is 8084. This is remote port, this is container and host port, which is the heart of the application, which I was talking about throughout my video. And there are webpack configs actually. Let me show again very quickly to recap. This is my webpack.dev.js. This webpack.dev.js is calling the remote, including this remote using the name and the port number and remote entry file. So whenever the compilation is done, it is saved into the remote entry.js file, and it is referencing that. And how these both connect? They connect using the WebSocket internally. So this is what Model Federation internally does, and it is abstraction for us. So don't worry, don't think much about that. And but this is a runtime. This is the runtime. Generally, it is not. We in the production environment, it is not a runtime. We implement. We always implement the this one build time, so that It is always statically offline way we get all the files, and even if any port is closed or off, there is no dependency. Okay, so don't worry, I will tell you that production deployment also. I hope you understand when I talk about this micro frontend video and this relations between container and the remote. So I'm going to create a detailed video also with production environment so that you can understand in this video only. After this video, I mean, up to the end of this video, you will understand and you will get that production environment which I will be creating. But I don't want it to confuse you. That's why I created very small application. I know this is meaningless to show red color, blue color, everything. See, I have started the port 8084 and it has come back, right? And if I reload this, it will show the code again. You see, so 8082 is also working properly. 8084 is also working properly, right? Same here. Yeah. So code is coming from this place. So I hope you are convinced with me that using the Webpack, how soon, how effectively we can create the micro frontend architecture. So this is not a real use case, but to understand, I'm very sure you can implement this by. I will share the code also. Don't worry, guys. Thank you very much. If you have anything, you can just comment me. I will be there to help you. Thank you very much. Bye bye. Let's jump on to the Webpack related code deployment strategies. There are different strategies which we can implement. I will discuss few things, few challenges also, few use cases also, and the best practices, so that you guys can understand. So deployment of micro frontend involves managing and deploying multiple independent applications. This is what you all know until this point. I have told you that it can be a different micro frontend repos, right? So each micro frontend repos will have a separate deployment procedure, and they have separate infrastructure also. One can have much bigger and good infrastructure, faster infrastructure. One can have smaller RAM infrastructure, whatever you want, depending on your different repo and the requirement. So, and the other thing is this way you can implement this deployment strategy of particular. So separate deployment is one of the key method which we can use for deployment. We can use the Nginx also, we can use the S3 bucket also, by the way. Okay, containerization. So containerization means you can have Docker and Kubernetes implementation, so that you can put your repo related code into that particular containers and execute that. So it will be very portable and scalable, right? You can have different pods. You can have one pod with good RAM and less number of storage, or whatever good number of storage, whatever you want, you can implement accordingly. Okay, and one way is to implement using CDN and caching. So when I say CDN, that means you can implement using content delivery network, because when your Webpack provides you a code, it will be a static code, right? And to leverage that advantage, you can push that code onto any S3 bucket also, any content delivery network also, so that it will execute on that domain also. Okay, so now CDN can cache and deliver their assets. You can put it on S3 bucket. It will be very high improved performance. You can use the cloud front on before that. So many things, like you can leverage the AWS resources and you can implement all these things. Okay, now you can use the service discovery also for communication between the micro frontends, and you can implement routing and URL management. But routing and URL management should be implemented on the container side or host side only, because otherwise it will be very, very confusing if you implement on all side, then you will have more maintainable thing. Okay, and routing between micro frontend is also implemented accordingly, and monitoring and logging is one of the key aspects which will be important in terms of production environment code. So monitoring and logging plays very important and vital role actually. Okay, why? Because you need to see when your code is not working, what errors you are receiving, and in production code nobody is going to see that. So for that you can implement Grafana, New Relic, or this kind of tools which will check for the performance also, and whichever queries are not working and stuff like that, right? You need to take care of the cross origin resource sharing. Why? Because if you implement, that is depending on your implementation way, they are maybe expected to communicate with each other, and they are on, let's say, different subdomains. So in that scenario, those subdomains, how they will share the code. So you need to implement the cross origin resource sharing for that particular domains, internal domains. And rollback and versioning system also you need to implement, because it may be possible that one point of time any one MAP is not working. So in that scenario, the best practice is to maintain the versioning of each micro frontend. Maybe depending upon the commit ID, or depending upon the date, or deployment name, or like that. You can implement load balancing depending upon the traffic. If there is a lot of traffic, you should implement the load balancing, so that there will be only one server on the front, and in terms of performance it will be very fast. Integration testing you can do using the micro frontend and data sharing and all the system. Automated deployment you can implement through the continuous integration and continuous deployment strategy. You can create the pipeline using Jenkins or AWS or any other method which we can do that, but it's very important. And always remember, since micro frontend is a complex architecture, it's not very simple. Why we are implementing this complex architecture? To get the performance out of it. Okay, so we know that this is complex, still we are doing that. So we must document everything whatever is there, because there can be change in the team, there can be different people coming in, they may know the technology, they don't know. So commenting, documenting, everything should be done very rigorously. And deployment should be a very happening after very careful planning and coordination, because once you do it, it's very difficult to change that implementation of the deployment. What I'm saying is, let's say you created the pipeline, and then suddenly you think that, okay, this is not the right way. It will be very difficult for you to change, because your website is live, right? And it will trouble you a lot. Let's talk about optimizations and performance related activities here. So one of the options is to split your code. As the name suggests and indicates what it is the meaning of code splitting, like you are removing, means you are only using the code which is required, and you are splitting it into the different folders or files or whatever, so that you will implement the lazy loading and you can use the code whichever is required, okay, on demand. You can configure also in the dynamic. I shown you, right, in the previous video I shown you how to implement the code splitting, how to have multiple entry points and multiple output paths, right? So remember that, you can do that. And this is the kind of checking the lazy loading kind of stuff. If module 1 is implemented or loaded, then only use that, otherwise show the error or handle the error smoothly. That's what is shown. So lazy loading is one of the important concept in micro frontend, because sometimes one of the repo can be shut down, and because of that system can go down, right? So in that scenario, you can use lazy and suspense fallback plugins actually from the React, and I'm sure there are given by the other methods also, other programming languages also, like Vue.js and AngularJS. But let's talk about React.js. Let's stick to that, so that no confusion. What I am doing is, by implementing lazy loading, is I am trying to import that into the button variable, and if that is implemented, that is loaded, then I'm checking here, means I'm wrapping by the react.suspense and fallback system. If button is not loaded, I will show loading symbol. As soon as it is loaded, within 1 second, 2 seconds, 3 seconds, I will show the button component. That's it. That's what I have implemented here. Let's jump onto the minification and bundling system. So this is again very straightforward. Let's think about minification. What is the minification? Minification means a big file is there, let's say 500 KB, 2 MB, 5 MB, whatever, and you are minifying it. Now you cannot cut the file actually, because it will not solve the purpose, it will break down, right? So when we talk about minification, what we do, we minimize it by removing the comments, by removing the extra spaces, extra lines, and there are some algorithms and some online methods also to minify, but we can do it using the Webpack also to get the performance. So we can do the minification on production environment, and we should do that actually, right? It's very important, and we should compress our images also. So built-in support is provided by Webpack. This is what I told you. And how you can do that? It needs a plugin. Plugin name is the Cursor Webpack plugin for JavaScript minification, and for the CSS minification you need CSS minimizer Webpack plugin. Very straightforward to use, don't worry. You can just import them in the Webpack configuration file and you can use them. Same way that I have used earlier. So you see here, it will minimize JavaScript and CSS file. I have imported that. You see on the first line I imported Cursor plugin. I have imported CSS minimizer. Then I have used them into the this way, optimization, minimize true. When I say true, that means it will minimize. If it is false, it will not minimize. And what minimizer will do, will execute these plugins and it will minimize automatically. So let's talk about bundling now. What bundling means, as I already told you, there is the entry point and there is the output path. So bundling is nothing but output path. Entry point is not a bundling. Bundling means after going through all the dependency graph is all the files, required files, it will bundle them into one particular file, right? If there are 10 JS files, it will give you only one JS file. There are 10 CSS files, it will give you one CSS file and put it inside the dist folder, or this can be configurable and it can be as per your choice. So this is the default practice, that why I have given this code, but you can do anything. So bundling refers to the static bundling of particular files and folders and all the dependency graph, and putting it inside the index.html so that it should work properly. Okay, the arrow shows entry point and the bigger arrow shows the output path. So as I understand, as you guys also understand, the output path will be dist folder and it will be bundle.js file. Only one output path file will be there. However, it will go through this index.js and create so many dependency graph calculations, put all the JavaScript into one bundle.js file. This is what a bundling mean. Okay, and run the Webpack build process. Running is very, very simple actually. The command will execute the configuration file and it will do whatever is required. So I hope things are very clear until this point, and you guys at least know what Webpack does, how it works, and what are the features Webpack provides to us and all that stuff, right? So let's talk about the overview. So when working with Webpack and micro frontends, there are so many tools and libraries which can streamline the development process. There are commonly used tools and libraries like module federation plugin, which is used to connect between the two micro frontends. I already told you. And you can have the single SPA framework implementation using the micro frontend and Webpack actually. What is single SPA? Single page application. It's very straightforward. Like page will not reload and it will work on the same page. Like, okay, that's the reason it is very fast. React.js is very fast because of the single page application implementation only. This is a micro frontend library. I don't know how to pronounce that, but I will pronounce Kinkun. Okay, and it has developed by the Ant group. It provides a complete solution for building scalable and flexible. This is very famous, guys. You can go through it. I cannot include this in this video because this was not supposed to be done for the Kinkun, but you can use that also. I am talking about React micro frontends only, and handling routing, communication between micro frontends and all that stuff, right? So system.js is again a dynamic module loader used to load modules from different sources. It's like it is also used in the micro frontend development actually, using the dynamic module loading and support different module formats. Loadable components is also another library which simplifies the code splitting and lazy loading in React applications. So I am telling you all the different tools which are other than the Webpack actually, so that you know, right? So this is one of the bundles, Webpack bundle analyzer actually, which is a tool that helps in visualizing and analyzing the size and composition of your Webpack bundles. So it will say it is kind of follow the tree shaking algorithm also, wherein it will eliminate the unnecessary code if it is not being used. So it is very smart. It will optimize your code as well as it will eliminate the unnecessary code from your system. And Lerna is a also tool which is used for managing JavaScript projects with multiple packages. Okay, so Lerna is kind of different approach actually. It can maintain the versioning and publishing the individual micro front-end packages. There are ways to implement Lerna also, and it is very famous by the way. Docker and Kubernetes, I already told you what they can do. Docker and Kubernetes, you can create different pods, containers. You can have your repos over there, and you can have very scalable application using Docker and Kubernetes. Using the CI/CD tools, you can deploy your applications like Jenkins is there, Circle CI is there, GitLab is there, AWS is there, AWS pipeline, AWS code commit, and everything you can implement to process your micro frontends. Okay, so let's talk about integration with React.js. Integration with React.js is very simple, guys. This could have the first video actually, probably, right? Because I was talking about React.js only majorly, but we can use AngularJS and Vue.js code also for creating micro frontends. Let's think. Let's talk about this. So you need to first of all set up the React.js code, and then you can install Webpack. How you can install Webpack? You see here the command. It's very simple, straightforward. The people who are working on React.js or Node.js, this is kind of very simple thing. npm install Webpack and Webpack CLI. This is important to, and this should be a saved. Why? Because we don't need this in the production. Okay, we only need in the local environment. And then we can create the configuration file this way. You see, I will explain you very quickly again because I know everything. I have already explained you. So what you did is here HTML Webpack plugin is included, then module federation plugin. I have received the path, the current path actually, current folder, and then specified the entry path. Then I am telling the output path where my files should go, in which folder and which file. And then I am talking about Babel loader. Why do we need Babel loader? I already told you, because JSX and new features are not understood by your browser. So you need somebody to compile that, polyfill that, and so that your browser, older browser and new browsers can understand. That's why we need the Babel loader. So we are using Babel loader in this one, our what I can say, Webpack configuration. And you can write SCSS wherein you can use mixins, variables, code reusability, inheritance, everything using the SCSS thing. And for that you need the CSS loaders and style loaders, so that it will create the simple CSS files so that your browser can very well understand. Okay, so this is the entry path I wanted to show you, and command for executing Webpack is this, and default configuration file can be webpack.config.js, but as I mentioned you that command can be, the file name can be different also. Don't worry about that. So I am calling npx command here, npx webpack, and then telling the configuration file name. It will execute your file, your webpack.config file, and obey your order, whatever you are asking, going through entry point, going through all the paths, parsing them, creating the bundle, and putting it into your set specified output directory. Okay, so this is the last topic I am going to explain you guys. Challenges faced. See, it is very kind of complex thing actually. It's not very straightforward thing. Webpack's configuration can be complex, not very straightforward for people like us to understand. But believe me, once you start working on it, you will enjoy it and you will fall in love with Webpack actually. Okay, so these things are little quite difficult to digest, that there are loaders, plugins, and everything different than the way we write the code. But guys, this is a bundler. It will work in his own way, right? It is not a programming methodology. It's a bundler. It will bundle the thing and give it to you by statically analyzing the thing, by optimizing. That's why this is a little bit complex than writing the code. So Webpack's initial build time can be slow. What that means is, whenever you build the code whenever you build the code, if it is a build time, it will take time. Why? Because it is analyzing your code, it is doing the optimizations, it is doing the tree shaking, removing the code, it is optimizing your images, it is parsing your SCSS files and creating the CSS files, it is parsing your JSX files like React.js and all, and creating the plain JavaScript, vanilla JavaScript related code. So it is doing so many things it does. That's why build performance can be little slower, but it's okay. It will a one-time job. But after that, once your system started, it will be work like a charm, because everything is single page for it, right? There are you can implement using the third party also, but there can be challenges, and some of the code may or may not work because of missing dependencies, because Webpack is just a bundler, it uses a third party, but how that third party thing internally works is not what Webpack's responsibility. Okay, so in such scenarios you may get encountered some errors, issues, so you may need to do aliasing, shimming. What shimming is, you might have heard about shimming. So shimming is nothing but make the newer code compatible with the old code, okay, old version. This is what is shimming is. So this is what I can say. And asset management, I already told you that fonts, CSS, images, everything it compresses, optimizes. But sometimes it's little tricky to understand what kind of compression techniques Webpack is being used, how it is working, and how it is handling these different assets and all that stuff. So sometimes it can be WebP, sometimes it can create JPG, PNG or whatever. So how you need to learn which method is more optimized for you. So sometimes it is very difficult to debug. I also agree. Why? Because whenever it will show the error, it will show from the main.js file which you have not created. So it will it will show the line number from main.js. So main.js file is bundled using the Webpack, and the line number and the code which is there, it is polyfilled code. That means you wrote some different code, it is converted and it has created different code. Right now this code is executed which you have not written. It is a simplified code which browser can understand. So it will show the error from that line. How you will understand? It is difficult. So in that scenario, learning how to generate and utilize source maps effectively can save time and effort during debugging. But debugging is not simple in the Webpack, and Webpack can be having the different version problems actually because of breaking things and major version changes and all. So you always be very careful about upgrading the stuff. Like if you go from Webpack 4 to Webpack 5, things may break. If you go from React 2 to React 3, React 16 to React 17, things may break. So you need to be very careful about that. In the Webpack and micro frontends, it has a steep learning curve. I told you in the beginning also, but you will fall in love. That also I told, right? It's okay to spend some time, but I'm very sure once you saw my this 2 hours video, you are much comfortable, because I have tried to explain you, shown the code, executed the code in front of you. I have explained that how micro frontends works. So even though it is having a learning curve, but I think the learning curve was only 2 hours, unless and until you are not doing hands-on. At least you understand the concept, you understand the power of micro frontend, you understand the power of Webpack, the different configurations, loaders, plugins, optimizers, tree shaking, so many different fundamentals. So I hope this 2 hours was my research from 200 hours. You got it in 2 hours only. So but you try to practice. I will say you try to practice it and execute, and then only you will understand. So you need to invest some time, obviously, which I already told you. Configuration options, best practices. So you can learn. You can go on websites, Google's, and you can check ChatGPT and all that stuff. So you need to do some hands-on, obviously, because only going through my video may not make you very expert. By going through my video, I can only guarantee that you will understand. You understood what is Webpack, how it works, what is micro frontend, and what all things are there, stakeholders inside this, right? But you need to have a hands-on practice. Guys, I have shown you the video also, code also. I am providing the code also here so that you guys can play around with that, and it will be very helpful for you. Okay, so for any queries or questions, you can send me message, you can comment me, I have a personalized account so that you can send me message so that I can be of help to you. Okay guys, I hope you enjoyed my video. Thank you very much for staying so long. And believe me guys, this was my research of around 200 hours, and I created this PPT, these programs for you. And this was not the fundamental production environment, but still I tried to create very simple programs which I shown you here, right, in my last videos. This I mean, this is the remote, this is the, so I will provide this code so that you can make some changes and learn by yourself also. Thank you guys. Let's meet in next series of my videos and provide the rating and review. Thank you very much for staying up to this point. Have a good learning. Thank you.